All right, so that's just a little bit of background connection. Let's jump into this real world problem so we can make sense of it. It says a rectangle yard is being separated into 4 equal sized sections for different items at a yard sale. So you just get a picture of this. We've got a yard, we've got a lot of things to sell. It looks like they're organizing it into housewares, toys, clothing, and books. So I'm gonna mark up my text and underline 4 equal sized sections. The area of the yard is 8x plus 12 square meters. So we know that the total space that the yard takes up, that's area, is 8x plus 12. So the area of the yard is 8x plus 12. How can you find the area of each section of the yard sale? So we know that there are 4 equal sized sections, and we have a yard that is 8x plus 12 square meters. So how could we find the area of each section? Well, if I'm dividing it into 4 equal sized sections, I'm just gonna write divide by 4, right? What is the area of each section? Well, I'm gonna say 8x plus 12. We know there's lots of ways to represent division. I'm gonna use the fraction way. Divided by 4. So the numerator is that linear expression divided by 4 because there are 4 equal sections. To divide, I say 8x. If I have 8 x's and I divide them by 4, that would give me 2 x's in each section. And if I have 12 divided by 4, that's going to give me 3. So each section would be 2x plus 3 square meters, because we're talking about area. All right, I'm gonna look at the bottom of the page so y'all can see a visual of what that looks like. Here is a picture of algebra tiles. We said that initially the yard was 8x, 1, 2, 3, 4, 5, 6, 7, 8 x's, plus 12 square meters, 3, 6, 9, 12, right? So it says the algebra tiles represents the entire yard sale. Fill in the length and the width, write an expression that represents the area in terms of the length and width of the model. So we just divided. We know this is 4 because there's 1, 2, 3, 4 rows. And when we divided this by 4, we found that 8x divided by 4 was 2 x's, and 12 divided by 4 was 3 1's. So 2x plus 3. There's 2x plus 3, 2x plus 3, 2x plus 3, 2x plus 3. So 8x plus 12 divided by 4 is 2x plus 3. All right. Here's some vocabulary that we need to add to our ability to talk mathematically. So we've talked about terms before, and we know this, this right here is a linear expression, and it has 2 terms, which are separated by that plus sign. Well, if you have a linear expression that only has 1 term, there's a special name for that. This is a linear expression that only has 1 term. It's called a monomial. You'll definitely want to write that out. Mono means 1. So if we have a linear expression that has 2 terms, 40x plus 120, like right here, that is called a binomial. Bi means 2, like a bicycle has 2 wheels. And if we have a linear expression that has 3 terms, one, 2, 3 terms, that's called a, can you guess? Trinomial. Okay. So that's the vocabulary that we're going to be working on today, monomials and binomials. If you look at page 230, we're going to be looking at number 1. It says find the greatest common factor of each pair of monomials. So, excuse me, we have 4x and we have 12x, all right? So here I have 1 times 4, I have 2 times 2. So these are the factors of 4, and these are the factors of 12. We've got 1 times 12, 2 times 6, and 3 times 4. And they both have an x. So remember, we're looking for things that they have in common. That's the common. So they both have an x, so I'm going to keep that. And the other thing that they have in common, well, they have 2 in common, and they also have 4 in common. We're looking for the greatest common factor, so I'm going to say 4. 4x is what they have. Okay? Let's try that out with 2. I have 18a, and I'm going to come over here so that there's space. I have 18a, and I have 20ab. All right, so whenever I first glance at this, I notice that they're both even. I notice that they both have a's, but 18a does not have a b. So this one both had x's, so I could automatically pull out the x. But since 18a doesn't have a b and 20ab does, I'm only gonna pull out the a, because you're looking for the things they have in common, the things that are the same. So I know that they're gonna have an a as a variable. Let's list out our factors of 18 and our factors of 20 to see what else they have in common. So I've got 1 times 18, 2 times 9, 3 times 6. So 1 times 18, 2 times 9, 3 times 6. Then I have 1 times 20, 2 times 10, 4 times 5, and I don't have any other I don't have any other factors for 20. So when I look at this list, they both have 1 in common, they both have 2 in common, and that's it. So my greatest common factor between 18a and 20ab would be 2a. All right, so we've got one more example before I let you try some on your own. Let's scroll down to number 3. Okay. So on number 3, it has 12 CD and 36 CD. 12 CD and 36 CD. Well, I immediately see that they have both of the variables in common. So I'm going to say my greatest common factor, my greatest common factor is C and D, because they both have C and they both have D. And now I'm going to list my factors of 12. 1 times 12, 2 times 6, and 3 times 4. And I'm going to list my factors of 36. 1 times 36, 2 times 18, 3 times 12, took me a second, and 4 times 9. I know there's no 5s, but there's also 6, so 6 times 6. I ran out of room, so I'm just going to erase this, squeeze them together a little bit more. We've got 4 times 9 and 6 times 6. Okay? You might not be able to see that from the camera view. All right, they both have 1 in common, They both have 2 in common. They both have 3 in common. They both have 4 in common. They both have 6 in common. 12 does not have a 9. They both have 12 in common. So my greatest common factor is 12. So the greatest common factor for 12 times C times D and 36 times C times D is 12 times C times D for number 3. Okay, so what we learned is terms or monomials can have variables in common. They can have common factors, which we're very familiar with. They can have one variable in common, but not both, like this problem. And they can have 2 variables in common, as well as a number. Now I'd like for you to, on the bottom of page 230, please try to find the common factors of A, B, and C. Pause the video now and try working that out. Make sure you pause because I'm about to show this work. Okay, for 12, I have 12 and 28C. So I'm gonna list 12 and 28C. I know that they don't have any variables in common, so C is not gonna be part of this greatest common factor. But I can list my factors of 12. 1 and 12, 2 and 6, 3 and 4. Now you have already listed this multiple other places, so if you want to look at a previously made list, you can. I've got 1 times 28, I've got 2 times 14, I've got, 4 times 7, and I think that's all the factors of 28. So when I look across the list, I see that they both have 2 in common and nothing else. So the greatest common factor is 2. Okay, I'm going to do B in a different color so it's easier to see apart. I've got 25x and 15xy. So immediately I see that a greatest common factor that they have is x. That's going to be part of it because they both have an x. And they both have 5s. So I know immediately that this is going to be 5 because 15 is not a factor of 25 and there are no other factors that they have in common. So 5x, and just to work that out, I've got 1 times 25 and 5 times 5. Here I've got 1 times 15 and 3 times 5. 5 is what they have in common. So your greatest common factor for B is going to be 5x. All right, now we're getting to C. I have 42mn and 14mn. So this is a lot like number 3. 42mn and 14mn both have mn in common. So the greatest common factor is going to include mn. Well, I also see that they have 7 in common. I'm going to skip count by 14s to see if that ends up being a factor of 42. So I've got 14, 28, and then 28 plus 14 is 42. So I know that their greatest common factor is going to be 14mn because there's nothing greater than 14 for this. So 14mn is going to be my greatest common factor for letter C. Okay, we've got a lot going on there, but just to review so far, we have learned how to find the greatest common factor of terms or monomials that include variables. So that's the new skill that we have developed so far. Remember, anytime during this video that you need to pause, rewind, and reflect, you are welcome to do that. I do expect all blanks to be filled in, so I know that you watched the video. All right, So this is saying I told you that the main goal for today's lesson is to factor linear expressions. So we just practiced factoring monomials. So we practiced factoring things that looked like this. But now we're going to practice things that look like this. 8x plus 4y. 8x plus 4y. Okay? This is a binomial. So this is how we're going to use distributive property to rewrite binomials in a way that says a factor that they have in common. So earlier in the lesson we saw 4 times 2x plus 3. Remember that little demonstration from the beginning where we had x, 1, 1, 1, x, 1, 1, 1, x, 1, 1, 1, x, 1, 1, 1. So really, we had already factored a linear expression right there. So this came out to be 8 x's and 12 ones. So 8x plus 12. I'm gonna erase this so it doesn't get confusing. 8x plus 12 can be rewritten as 4 times 2x plus 3, because I found the greatest common factor, which was 4, and then I pulled it out of both of these. I divided it into both of these numbers. 8x divided by 4 was 2x, and 12 divided by 4 was 3. So I can rewrite that as a multiplication problem. 4 times 2x plus 3. That means that I have 4 groups of 2x plus 3. Okay? So we're going to take a look at that now. This says factor 3x plus 9. So I've got 3x and I've got 9, and I need to find the greatest common factor. Well, 1 times 3 is 3, 1 times 9 is 9, and 3 times 3 is 9. So my greatest common factor is going to be 3. 9 doesn't have an x, so that can't be included. So I'm going to write my 3, and then I'm going to write a parentheses. What is 3x plus 9 divided by my greatest common factor? Well, 3x divided by 3 is just x, 1x. And 9 divided by 3 is 3. We can see a picture of that here. I had 3x plus 9, and I divided them by the greatest common factor to get 1x plus 3. 1x plus 3, 1x plus 3. Okay? So, let's take a look at number 5 on page 231. It's so weird not to have you guys here asking questions along the way. I feel a little bit nervous. Whew. Okay, so on this one, sometimes you're going to encounter a situation where there are no common factors. So let's check this out. I've got a binomial of 12x plus 7y. So if I list my factors of 12x, I've got 1 times 12, 2 times 6, and 3 times 4. If I list my factors of 7, that's even easier. I just have 1 times 7, because this is the prime number. They don't have anything in common besides 1, so we know because of the identity property, 1 times anything will just stay the same. So here, I cannot factor this any better than it's already factored. If they do not have any common factors greater than 1, you can leave it the way it is. So this would just be 12x plus 7y. Because look, if I pulled 1 out, 12x divided by 1 would be 12x, and 7y divided by 1 would be 7y, because it stays the same. That identity property tells us it stays the same. So 1 times 12x is 12x, and 1 times 7y just ends up being 7y. So there's the same. I'm going to give you a few minutes to try D, E, and F. All right, hopefully you remember to pause the video. I'm going to work these out now. I've got, in this binomial, because it has two terms, I've got 4x and 28. I have to look for the greatest common factor here. 1 times 4 and 2 times 2 are my factors. Here I have 1 times 28 and 2 times 14 and 4 times 7. My greatest common factor is going to be 4. So here we go. I've got 4x minus 28 divided by 4. That's going to become 4 times, remember I pulled the 4 out, I'm dividing by 4, so I need to write it right here. 4x divided by 4 is 1x, minus 28 divided by 4 is 7. Or I could think about this as negative 28 divided by 4 is negative 7. So this is the factored expression. I can check that by saying 4 times x is 4x, and 4 times negative 7 is negative 28. Okay, for E I have 3x and 33y. They don't have any variables in common, but I do see that they have 3 in common, so I'm gonna assume that you guys see that too. So I'm gonna pull up 3, and then I'm gonna say 3x divided by 3 is just x, and 33y divided by 3 is 11y. So 3 times x is 3x, 3 times 11y is 33y. Okay, right here I have 4x plus 35. This is even and this is odd, and I know that 35 cannot be divided by 4 and it cannot be divided by 2, so this is going to stay the same. 4x plus 35, because there are no common factors greater than 1. Give you a chance to pause the video, copy down anything you need to copy. We will be reviewing this on Monday when I return, so if you have any questions and you have Ms. Jenkins in the room, please feel free to ask. Otherwise, write down what you have, what you see, and then we'll go over it again on Monday. Put big question marks. All right. So this is full circle. It brings us back to the original part of the lesson where we have a real problem. We have a garden that has a total area of 15x plus 18. We have to find the common factors to know how can we, instead of the original problem told us that it was going to be divided into 4 equal sections, but we don't know what this is going to be divided into. That's what we're trying to figure out. So I have 15x plus 18, which is the total area of this, okay? I'm going to figure out what I can divide both of them by. Well, the factors of 15 are 1 times 15, 3 times 5. The factors of 18 are 1 times 18, 2 times 9, and 3 times 6. So the factors that they have in common are 3. So I'm going to rewrite this to say 3 times what is going to give me 15x plus 18. Y'all kind of did a problem similar to this on Tuesday where you had to create your own expressions that equaled an answer. So here's your answer, and here's your answer, and you're having to create an equivalent expression. So 3 times what equals 15x? Well, I can divide by 3 to find out. 15x divided by 3 is 5x. I can divide 18 by 3. 18 divided by 3 equals 6. So here I have 3 times 5x plus 6. And class is going to begin, so I've got to stop.